Hello friends. So today we are going to start with the ArcGIS tutorial in which we will see the most fundamental topic of watershed delineation in ArcGIS. So this watershed delineation is actually, if we say as a hydraulic engineer or as a hydrologist, this is the most fundamental step that you should be able to delineate the watershed, particularly using this ArcGIS software. However, this ArcGIS software is, you can say, it's a paid software, but sister software, you can say QGIS is also available, which is an open source software where the more or less the commands are same. You can practice the same thing. So before starting from the very basic, by seeing the software, the understanding the interface, how to start as a beginner, we will cover everything in this current video. However, just to get an overview that in which direction we will be moving, how we will start the process of delineating our watershed, particularly for our use, how we can use this delineated watershed further in our analysis, all we will see through this PPT. After the completion of this PPT, we will switch over to the software. We will try to see the commands. We will try to draw one pilot study area. We will delineate one watershed of our own, and we will understand everything, that what are the raster files, what do you mean by the vector files, what is DEM, how from the DEM we get the watershed. All those basic doubts that as a beginner we have, we will try to solve in this thing. Also, we are open to the comments and queries. You can always have my details, my email ID is there. You can always raise your query if you have any doubt regarding the current video or the topic related to this thing. So first and foremost thing is, what is watershed? So, in a nutshell, we all know, but just to begin our lecture series, so this watershed is actually a area that drains the water to a common point outlet. So that common point is all known as outlet, and what is this? What watershed is actually? Watershed is actually a, a total area that drains the water, and all those waters comes to one common point, and that one common point is outlet. Somewhere it is also known as pour point also. So upstream to this pour point, whatever this divide is created, it is the watershed. And we say that if a water falls in anywhere in this watershed, ultimately it will be carried to this point, outlet point. So this is the watershed. Now, what is the current objective of our video today? That we will identify this watershed boundary, we will see the drainage pattern, and also we will try to evaluate this catchment area. So all these things we will cover in this topic. Now, to start with this problem, that delineating the watershed, the only input that is required is the digital elevation model. You can say DEM file. Now, what is the DEM file? DEM file is very much similar to the contours, you can say, that we use in our survey. So in survey, we take the contours, we draw the contour lines. Now, being advanced through this software to satellites images, now the satellites takes the data. Now those satellite, that data that has been taken by satellites, they convert those data into a digital elevation model. You can say DEM, and DEM file is accessible free of cost through the Bhuvan portal. I will mention the Bhuvan, BHUVN. I will give you the link in the description also. So from that Bhuvan portal, in India, as per your interest, you can download those DEM file, and the format of that DEM file is the TIFF format, TIF. Okay, so you can download that DEM file and use that DEM file as the input in the ArcGIS software, and using this DEM file, you will subsequently reach to the watershed delineation by following some steps. And what those steps are? Those steps are basically explained in this 6 point, and the command that is executed in the ArcGIS is the hydrology. That is the command in the spatial analysis tool where we get this command hydrology. I will show you in the ArcGIS software also. Just a overview that what we are going to do. So once you have the DEM file, a TIFF file, what you do, you just follow the command of fill sinks. You just fill the DM. Why to fill the DM? Because if suppose satellite has not taken the data somewhere or missed the data, there are some gaps. So it uses the neighborhood data point and it used to fill so that your DM is a continuous file. There is no breakage in that DEM file. That's why we run the first and foremost command is the fill command. Then once the DM file is ready, it is free from the unexpected gap or very high, you can say, differences between the neighboring points. Then we go for the another command that is the flow direction. Now flow direction is the another D8 method is there. What is the meaning of D8? I will tell you in the subsequent PPT also in the coming slides that what does D8 method is. Then after the flow direction, you come to know that okay, what is the flow direction in my catchment? Now that flow gets accumulated. So next thing is that you run the command of the flow accumulation. Now once you have the flow accumulation, now you define the streams, that which streams are the major streams that is bringing those flows. Now once you have defined the stream, the next point is at which point of interest you want to get your watershed. For example, if you can see in the previous slide, this was my point of interest. So you can say whole this was my DEM. There was some streams. I have identified as streams. Now my motive is to get one point feature where I, at the upstream of which I want to delineate my watershed. So this is the 4-point selection method. Now once you have got your 4-point, now there is another command of watershed delineation. You delineate the watershed. If once this watershed was delineated, now it is the part of the subsequent calculation that how you convert this watershed into a vector file. Okay, so there is a difference between the raster and the vector file. Whenever we go for the calculation, for example, the perimeter, the area, we need the vector files. And the vector files are, you can say, other files that are the shape files, which could be a polyline, which could be a polygon, or which could even be a point line. So those shape files are the vector files. And the raster files are basically the TIFF files, TIF. Okay. So this is the difference between the raster and the vector file. The calculation part, all those are done in the vector file. So this in our whole session we will executing all these 6 steps. Once we have the watershed delineated, then we will try to extract the streams, the DEM of the watershed, and we will see that okay, how the watershed is being delineated. So this is just a more detailed steps that we have discussed. We have just chalked down okay that what are the steps involved. That when we do the fill sinks, we go to the spatial analysis tool, the hydrology. Then we will use the command fill. We will, what does this command do? It removes the depression in depth that traps the flows. It ensures continuous flow path. That is already discussed. So just a discussion. Okay, so this the 8 method I was talking about is flow direction. Suppose you are here at this center. Okay, suppose you are here. Now this pixel has if the number is 1, so this is 2 to the power 2 to the power 0, 2 to the power 1, 2 to the power 4, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. So and altogether we have this 8 points available. So this is the 8 direction. If suppose any pixel is having the number 1, it means it has the water has a tendency to flow towards the east. If it has the number 64, it means the water has a tendency to flow towards the north. And if it is 4, then it has a tendency to flow to south. Suppose if a number is there in a pixel as 32, it means water has a tendency to flow towards the northwest. Okay, so 32 is northwest. So in this way, it is decided that okay, if we have some number, then what is the direction of that flow, where will be the water will be flown, and in this way it accumulates, and at the end we will see that when we go to step 3, the flow accumulations, it accumulates the number of upstream cells that flows into the each cell. So high accumulation value indicates almost the stream channel, means there are many sub streams that joins into a stream. So the accumulation values goes on increasing, and the highest accumulation values is the main channel, you can say. Now once you have the flow accumulation, then you define the stream, because there are many streams. So you try to define the main streams. So for the main streams, we use the raster calculator. We will see that how we can define the main streams. Then the 4 point selection feature, and the next is the watershed delineation using the watershed tool in the hydrology. Next, now final step is that we need to convert this raster to polygon. Polygon means the vector. We are raster to vector. Why we are converting all those raster files to vector files? Because we need to do the uh, you can say mathematical analysis, like what is the area, what is the perimeter of the watershed that we see. Now final output what we get, this is somewhat we can say that this is our aim, that we want to get a watershed which has the, you can say, these are the points marked. I have taken this snapshot where I have the multiple watershed, and this is a Chhattisgarh state, you can say, area, and this color shows the, you can say, the DEM. The red color is at higher elevation and the blue color is at a lower elevation. So you can see that the from red to blue the water is flowing in that direction. So we can get one rough idea, okay, our stream is maybe in this direction, because we have the blue line in this way. So all the streams are flowing through this direction, right? So one thing more is there, that is to be focused here, is that this is the watershed, and we have the boundaries, we have the multiple sub watershed also. The point marked in this yellow clip is actually a point of concern that we have seen. If you take any of the points, suppose I take this point, so it means it has this catchment that is being associated into this one. So if I take this point, it means this is the subcatchment that has been drawn. So if I take this point, it means it is the bigger catchment that was being drawn using this point. So from the major watershed, we can also delineate the sub watershed. So we will see the exercise are very similar. So first of all, we will take very simple case. We will take one DEM that is already being downloaded from the Bhuvan side, and we will try to see all those steps, and we will come to see the end of this picture, that how the watershed is being delineated. Secondly, after watershed you have got, then it is used for many purposes like runoff modeling, flood analysis, the sediment studies, and it also forms the basic for the hydrological and environmental assessment tools. Okay, so this watershed is the, you can say, beginning step for the hydrologist, at least, so that you can proceed further analysis in that catchment, right? So as a beginner, suppose you have the ArcGIS software that has the taken from the institute, or you have the subscription of this. So you need to open the ArcMap. You just open it. So this is the opening of the software. It's a beginning of the software, how this software starts. So whenever since I'm starting a new map altogether, so I will take a new map and my templates. I will select the blank map, okay, and default it is selecting as a geodata base for this map. So this is the default location, I'm okay with it. If suppose you want to save it to some other location, you can definitely change it from here, but as of now I will be just taking the default location, and I will say okay. Now, once you click OK, so this is the interface that you get of your ArcGIS, right? So this is the interface. Let me disable my video. So this is the interface, right? Now we have some, you can say, Arc Toolbox command. All the data are here in this command. You can say search window, the Arc Toolbox, and this is the, you can say, Python coding. This is the model builder. So all those commands that we have seen, that spatial analysis tool, that is covered in this Arc Toolbox. You simply click onto this Arc Toolbox, you pin it, so it will be pinned to this location. You can see. You click on the Arc Toolbox, you will see all those tools that is required for your delineation. And there are other purposes also, but as of now, we will use this Arc Toolbox for our analysis. And this is the table of contents. So whatever file that you will open, that all will file will get reflected here in this table of content layers. Okay. uh, to add some, to start, you want to add some DM file, or you want to start your thing, so you can see there it is written add data. So plus sign is there, add data. You just simply click on this and add some data. Now it is asking that which data you want to add. So for the delineation of the watershed, the first and the only data is required is the dem file. So I will just see that in which folder I have cut my dem file. I will try to uh, go to that dem file and install those dem file at whatever we have seen. Right. So I have my data, and so this is the dem file .tf format, .tiff format. So I am just adding this data to my layer. So it is saying that data is insufficient pyramid. So you click on yes. So you can see that percentage is going on here. Since my dem file is a little larger, that's why it's taking too much time. Otherwise, you can start with one or two tiles. But my data set is having almost 17 to 18 tiles are there. One tile is 30 by 30 meter, and you one pixel size is 30 by 30 meter, and this is the size of the one tiles. It has many pixels. So I have downloaded this tile, and then later on I have mosaicked those tiles to get one single tile, and this is being downloaded from the Bhuvan site. So from the Bhuvan site, you can also, I will just share you the link, you can also download for your area of interest. Right now my area of interest is the, you can say, Chhattisgarh state, and I am particularly focusing on the Mahanadi Basin. So I will try to delineate the one of the watershed in the Mahanadi Basin, right? So you have downloaded this dem file. Now the first and foremost step that was required was that to fill the sinks. So we will see our analysis toolbox. We will go to this arc toolbox. We will see this spatial analysis tool. In the spatial analysis tool, I think you all can see there is a tool known as hydrology. You can see a command hydrology. You just click on this plus button. Now the first is written basin, then fill. So use this fill command. Okay, use this fill command, and it is saying input the surface raster. So the surface raster is the whole dem file. Okay, so I am just selecting this dem file. Now it is saying that what is the output surface raster and where you want to save it. So I want to save it to that same location where I have used the uh, content. So I will use here the term, you can say this is my fill DM. So I will use the filled DM And since it is raster file, somewhat you have to add the .tiff to it. So I will add .tiff. In raster files we used to add some, in some software, in some upgraded version you don't need to add the file extension, but since I, in my thing, in my system, in this particular version of my ArcGIS, I need to add this extension. So I'm using this extension .tiff and I'm saving it. Now Z limit is optional, so I just ignore it. I just click OK. So now it is processing, and you can see that the fill command is running in it. So we have the dem file and the fill command is running. Once the command will get executed successfully, you will have one another layer of the filled DM that you have created, and it will reflect in this table of content. We will wait for a few seconds, depending upon uh, the machine that you have, the how the processing speed is there, and the size of this temp file. Since I have the larger size, so I think it will take some time. So anyway, in between we can see that, let it get complete. So we have this fill command. It will remove the depression in the dam that traps the flow. It ensures that a continuous flow path is there. So once you have this filled DM ready, then we will switch on to the flow direction. So still it is running, I guess. We can also check for the results. There is a result toolbox is also there, where we can see that, okay, search is there. Okay, so this fill command is being executed. You can see that it is written fill and tick mark is there. So this has taken place, and you can see that filled DEM, that raster file is created here also. And now this filled DEM is comparatively, you can say, filled with all those lags if there were any. And you can also compare that low and high values are in the same order as we have the DEM file. So that is the thing that you can notice here. So I am just okay with this. Now I am ready with this fill DM file. Our next part is to go to the flow direction. So I will click on the, again, the arc toolbox, the hydrology, the flow direction. Now it is saying that what is the input surface raster. So this input surface raster will be now my filled DM. Since I am working on the, I have already filled my DM, so I will take the filled DM as my raster. Now it is saying that what is the output flow direction where you want to save it. I will save it in the same location where I have used my filled DM. So I will say that this is flow direction of the DM, and this, since it is also a raster file, so I will just save it as .tiff file. I will save it. So it's written here the flow direction type optional D8. So I have already explained what is the meaning of D8. MFT is also there. DINF is there. These are the method of just calculating the direction. So in particular, I am using the D8, and optional command by default ArcGIS takes D8 value. So it's okay. We can go with the D8 value. Now you can see that this flow direction command is running, and it is written here flow direction. So once this flow direction will get completed, it will, the flow direction DM and that create that raster file that we have created will be reflected in my table of contents. Okay, so flow direction file will be ready for the use. This is the flow direction. We have already discussed this thing. So this d8 method, by using this method, it is calculating, okay, what will be the direction. So when we will have this completed, uh, our our software when I have completed running this flow direction file, you will see that our legend will show you the values of 1, 2, 4, 8, 6, 32, 64, 128. It is still running flow direction. If you proceed with the smaller DEM file, then the processing will be very fast. So you can see that this is a flow direction. A tick mark is there. It means it has been done. The file is ready. Flow direction dot underscore dm dot tiff that we have named. And you can see that 1, 2, 4, 8, 6, 32, 128. All those the colors. Now you can understand yourself that what does it mean. If suppose you have the number of pink color of, you can say, green color 64, so you are pretty sure that this what 64 is actually direction of in the north. Okay, that we have shown 64. It means water will be going in the north direction. So if you zoom in and you can see, then you can figure out, okay, so in the north direction the uh, command green one so water is going actually this way. Okay, you can see water is going this way, right? And the 16 is again, you can say the direction of the 16 is the towards west. So this is going west, this is going, so at the end you can say all those pixels are accumulating and going in this direction. Okay, so towards the north, and the main stream is actually lying in this direction. That's why it is showing this way command. Anyhow, we will also see uh, in the subsequent analysis that what is that stream direction and all those things. So flow direction we have got. Now next step is the once you have the flow direction, you need to accumulate this flow. So I will now run the flow accumulation command from the same R toolbox, the hydrology command, then flow direction. Sorry, flow accumulation. So I will click on the flow accumulation. Now the requirement of this flow accumulation is actually a input of the flow direction raster, and flow direction raster we have created just now with the name of flow direction underscore dem dot tiff file. So we will select this one. Now it is again asking where you want to save it. I will just save it with the name of flow accumulation of the dm file dot tiff. Since it's a raster file, I'll save it. The optional things I will not change, nothing. Okay, and the flow accumulation file is now running. You can see the flow accumulation file is being running, and it will now create the flow accumulation. uh, you remember I have told you that if you have the higher value of the flow accumulation, it means that you are actually getting towards the mainstream. So when this command will end up executing, you will see the legend, the values will be at from lower to very high values, and you will understand that okay, that high value is actually for those pixels which are the mainstreams. We will see to it. I have taken purposely the larger DEM file because in this way you can get multiple watersheds. You can have the idea of the multiple watershed. I will explain with the one watershed, but I will share this file in my drive for the viewers. They can download those file and they can try themselves the procedure that we have discussed in this ongoing lecture. It will be very beneficial for all of us. So this flow accumulation file is running. Once this flow accumulation will get completed, we will see that the legend of this will have some low value to very high value. Meanwhile, Let me have this sip of water. It takes time actually, since the files are large, and although I'm using the workstation, if you have some inferior configuration laptop, it might be taking more hours of time. But since I am working here on the workstation, so still the time, the computation time is less from my end. Anyhow, we will see that flow accumulation. There are many things that we will also see how to uh, get the vector files also. Meanwhile, we can see our presentation that okay, which steps we have completed. We are already on the step 3, the flow accumulation. Later on, we will move on to our step 4, where we will be defining the streams, and we will see. Okay, so flow accumulation command has successfully completed. You can see it is written flow accumulation. Now you can see the flow accumulation DEM value that you have got. It is of order of 9 into 24/7. I told you that it's going to have the very high value. So this flow accumulation dem.tif file has the very high value. Now we need to uh, map those algebra. We need to get the streams of our preferences. So we will define these streams as being the next part of our analysis. So for defining these streams, we will go uh, to the map algebra, we can say, tool, and we will perform the raster calculator. So once we open the raster calculator, so it is asking that which layer or variable do you want to go for the raster calculator. So the flow accumulation dem file I am using, and I want that this I want to cover only those, since the numbers are very high, so the streams that are greater than, you can say, 3000, or you can say 4000. So as of now I am using 3000. Even you can go for 4000. So so streams that are greater than 4000, I need that calculate those. uh, uh, Rest will be, so the greater than 4000 number will be a 1, and less than all those 4000 will be a 0. And the output raster, I want that this is the, you can say, uh, this is again a flow accumulation that .tif file that I have required. So I will save it, and now I will say okay. Now once this raster calculation is being going on, going on, we will see that okay, now we will have the some picture of 0 and 1. The 1 will show you those pixel values whose stream cumulative value is more than 4000, and 0 means those are less than. So this, in this way, it will be easy for us to understand okay, which are my streams, main streams. I will just show you. So you can see here the 0 and 1 we have got. We will so raster calculator is done. So 0 and 1 pattern, you can see, is being shown here. I will zoom in, and I will also show you in details what does this mean. So if I zoom in, you can see those dots are actually streams that are being done. You can see. Can you see it? So these are actually the streams. Now I just double click on this symbology, and I will say that the current symbol The current symbol of this flow accumulation symbology, I just use 0, so I will say white color, and 1 is actually a blue color because it is stream, so I just apply it. So now you can see this is my stream. Okay, now these streams I have got, but they are the raster file. They are not, still they are not in the vector file, vector format. Now I need to convert those raster file into the vector file, and streams are the polyline features. So I will use our toolbox, and I will see that how to convert this raster file to the vector file. And this the feature of this raster file, to convert into the vector file I will use the polyline feature. So my next step is to convert these streams into the vector file. So I will go on the toolbox. I will see the conversion tool. Conversion tool is from raster. You can see it is written conversion tool from raster to the polylines. I am not using the point because I know the streams are not the points. I am also not using the polygon. Why? Because they are not polygon. They are not closed. They are having some features which are in the form of lines, and they are multiple lines. So the word polyline have come. So I will use from raster to polyline. Now it is asking, okay, so what will be the input raster? I will say the input raster is the flow accumulation, and you can see that they have take it, the options are coming of those only which are 0 in one format, because it is easy for the ArcGIS to understand, okay, this is the newly formed, and it is only have to convert those which are in the one form. So field values, I have used this input raster as a flow accumulation. The output polyline features, where you want to save it. Yes, I want to save it. And I, since now I haven't saved any shape files, that is why it is written here feature classes. Now it is not raster, it is the vector file. So I will save this as the streams vector. So, okay, this is my nomenclature. You may use anything, but you need to understand the basic things that, okay, now we are converting all those my raster file to the vector files. So I'm saving my streams from the raster to the vector, and I am just clicking save. And background values are 0. Simplify polylines, it's optional. I just click on OK, and the command is running that raster to polyline. Okay. So we have this command raster to polyline, and it will convert. Now you can see that our streams vectors are ready. Now these are my streams vector. It looks good. The color is green. I will turn it, I will make it blue because streams are generally blue. And so I will make it blue. Just you click on the, you can say the polyline feature. It is asking you which color. It is given that for the river it's a blue color. I will use this blue color. I will click on OK, and this will convert into the blue color. You can see. So all these are my the blue colors. Now what is being done till now, that we have got the flow direction. From the flow direction we have got the flow accumulation. There's accumulation, we have chalked down that those streamlines which are more than 4,000. Then after that we have converted those streamline features, these streams features, into the vector features. Now the next step, as we have seen in our PPT, we have done this part. The next part is the 4 point selection, or you can say outlet selection. Now you need to define a point feature as a watershed outlet, and then use that point feature in our ArcGIS to generate a watershed. Suppose I have one point, say where I, which is area of my interest, that at this point I need to have the watershed. What will be the value? Now there are many ways that you can put the point in the layer file, but I will try to show you some advanced, or can say some different methods so that you can have different learning also. What is that? I will try to insert one KML file. I guess you all know what the KML file is. KML file is basically a uh, you can say the file that consists of many points or many locations into it. Generally in you can say Google Earth, we used to have those KML files so that we can see the location of the different point in the Google Earth. So what I will do, I will try to include the KML file in my layers, and using those KML file, I will try to chalk one of the point from it and convert it into shapefile and use it as my point feature. I hope I am very much clear what I am trying to say. So first and foremost step is that I will bring one KML file into my layers. So to bring the KML file into the layers, you just click on the search button, and you just pin this search also because sometimes it's very much useful. So you need to bring one KML2 layer. So you just type KML2 layer and you just do the search. So it is saying that okay, if you have a KML file in your system, then I will bring it to the layer, and you have to just run this command. I am using this command KML to layer. It is asking that yes, input your KML file. I have the KML file, and see the KML and KMZ files are almost same. This in the same folder where we are working, we have this KML file. You can say I'm working on the same folder, and since the type is selected KML file, though I am using this KML file. And you just output location, it is asking yes, output location I want the same. So this is, you can say, 4 points, or you can say outlet points. So I'm just using outlets. Okay, so I just added uh, I just added here output location. What is the name you want? I want to name as 4 point, you can say. So this is the 4 point, or you can say outlet. Somebody says outlet also. So outlet, I say okay. Now you see that we will have this KML to layer file also included in our system. Now you can, since I was having many points for which are the point of concern to draw the feature, to draw the watershed. So altogether I have multiple points, and the important thing is to note here is that your point should be on these streams. Otherwise the watershed that you will delineate will not be correct. So you need to zoom it out, and you must see that okay, whether your point is on the stream or not. If suppose I am taking this point Kurubhata, and I see that no, this Kurubhata is not on the stream, it is far away from the stream. So I need to bring this point into the stream. Now what I will do, I have the 4 points outlet are available here. Suppose I select one uh, any location, you can say any point that you want to draw the watershed. So for this location Kurubhata, as of now I want to draw the watershed. So what I will do, I will select this feature. There are many ways that you can do, but I am using this. I have selected this feature. Now I will just open the you can say the attribute table, and you can see that in the attribute table the Kurubhata is being selected. Now what I will do, I will import this, or you can say I will export this point as a shapefile. These are as of now the points, they are not the shapefiles. And for the I need my points to be in the form of the shapefile. So what I will do, I will just right click on this point, and I will go on to the data. I will export the data. Now it is asking which data you want to export. You have seen that there are many points in this file, but since my point of concern is Kurubhata, I have selected Kurubhata. You may select the multiple points also, and you just, it is written that export the selected features, not the all the features. So I am selecting the export feature, and use the same coordinate system as this layer source data or the data frame. I will use this data frame, and I will output feature class will be in the form of shapefile. It is written .shp, and I will give the name of this as the 4 point location is say Kurubata. It could be any location. So just for my understanding, I'm using 4 point at Kurubata. I just say okay. So it is saying, do you want to add this exported data to the map as a layer? Yes, I want to add this. Now you can see this is now a shapefile, but still this, you can see this is not on the, this is far away from the data of the streams vector, so it is very much away from those. It is not on the flow accumulation line. You can see it is at a distance. Now the first and foremost priority is that we need to place this point feature on the line of the flow accumulation. If it is not there on the flow accumulation, then it delineated watershed will not be correct. So what we do, we just try to edit this point. And how to edit this point? We will go to the we will right click this, we will say edit feature and start editing, right? Now once you have started editing, it will ask you to select the point. So I will select this point. It is selected, you can see. Now you just move this point, you just move this point to this location. Nearest point is the same point. So I am trying to shift to this location, because once they are at the water pixel, then only the watershed will be get delineated. So the point is shifted. This is just a name. If you want to shift this name also, then you need to click on this point symbol and you need to shift this. But as of now, I am only concerned with this point feature, and its name is 4 point Kurubhata. So my 4 point is on the water pixel, you can see. I am just zooming in to show you that yes, the point is here. Now, if I delineate my watershed using this point, whose name is 4 point Kurubata, I will get a correct watershed. Now, I have since started my editing, so I need to stop my editing. So I will say save edits, then I will stop editing. Now this point has been shifted to this place. This is just a pinpoint, it is not mattering at all. Once I will go for the watershed delineation using my hydrology tool, I will use this point as my point feature. I will show you. When you go to the arc toolbox, you have the hydrology toolbox. Now there we have the watershed delineation. This is the last step, that after the 4 point selection we have to go for the watershed delineation. You can see in watershed delineation it is available in the spatial analysis, hydrology, then watershed, where we have the uh, input as whatever that we will say to it. So just we will click on watershed. Now it is saying that input the flow direction raster. So flow direction raster, we have the file. This is the flow direction dot d underscore dm dot tiff is the raster file. So we will use that. Now it is asking input raster or feature 4 point data. So the feature 4 point data is the 4 point Kurubhata. This is the uh, feature 4 point data that we have created. Mind it, be very careful that these points are not my that data, because we have edited it and we have got this shifted this to the 4 point Kurubhata. So this is our point of interest. Now Output raster, it is asking in the form of raster. So definitely we need to save it as a watershed. I am saying this is my watershed at Kurubhata. This is the point location, and I will say dot .tif file, right? So this dot .tif file, I will save it and I will run the command and I will say yes, okay. So this is the point of and send that, okay. We have the watershed is being delineated at this point. It is written watershed. The command is running. Now, meanwhile, the command is running. I just show you. I just want to show you one thing. Okay, so this was my point. So my watershed, that once it is delineated, it will be from this point only. Now, the lat long of this point is, you can say it is written here. Wherever you will move your cursor, the cursor will show you the lat long of those places. So for this place I am saying that lat long is C. Watershed is being delineated. I will zoom out and show you, but before that I want to show you very very important thing here is that at this point we have the lat long of this point is you can read from this place, you can say it is 83.204 and 21.987 decimal degree. So I will just note it down this lat long 21.987 and 83.204. I will tell you that why I am noting down the uh, value of this lat long. So let me write it down in somewhere at 21.98. It was 21.987 and 83.204. 21.987 and 83.204. Okay, so now I just zoom out and I will show you that what is and how the watershed is being made at this place. So you can see that the Kurubhata, this is the location and this is my watershed that is being delineated. Now this watershed is a TIFF raster file. It is not a vector file. I am just saying you because we have just created a raster file. You can see watershed kurubhata.tif. Now I need to convert this raster file into a vector file. Why? Because all my calculation of the area, the perimeter is possible only when it is a vector file. So I will convert this raster file into a vector file. I will use the arc toolbox and I will again use the conversion tool from raster. I will click on conversion tool. I will go from raster. Now raster to all those point, polygon and polyline, all these are the vector file, but for my watershed I will use my polygon. Why? Because this is a close, you can say, polygon type of thing, and I will use this raster to polygon. It, it is asking you input the raster file. The raster file is the watershed that is being deleted at the place of Kurubhata, and the output polygon feature, now it is saying polygon feature. So I will say the polygon feature is my watershed at, you can say, Kurubhata, and it is a vector file. Because now since it is a vector file I will not use .tif, it is already shape file. See, vector files are the shape files, so it's automatically takes .shp format. So I will use save. Now I will run the command OK, and it will generate, it is converting my polygon raster to polygon. Now I will get a watershed that is a vector file. So this is the watershed and we have got here as a vector file. Now you can see that this color, block color, this is showing you the uh, area that has been converted. So I will just click on this, I will make it hollow, and I will make our boundary outline more thicker to get to show you. So this is my basically vector file now. Now since this is my vector file, I can get the area of this file. So I will just right click, I will open the attribute table. In the attribute table, you can say I will add field, and I will field add the area where I will use the float, and okay. So I will calculate area, I will calculate geometry. Area is disabled. Why? Because it is not in the projected format. So I will use the projection also. I will use the properties in the layer, the coordinate system, and I want my coordinate system to be in the projected format, not the geographical coordinate system. Once it is in projected format, then only you will be able to calculate the area. So I will use this projected coordinate system. I will go to the UTM, and in the UTM, the WGS 194 Northern Hemisphere, and our area comes under the 44 North zone. So WGS 984 UTM zone is 44 North. So I will use this zone and apply. So okay. Now all my data are now in the projected format. Now I will be able to calculate the area. So I will use the calculate geometry. Now it's asking property area. You can see now it is able because I'm using the data frame, coordinate system of the data frame. This is my data frame, and I want to get area in the kilometer square. So I'll use this kilometer square. I will click OK, and I have got the area as 4733.97. So this is the area of the watershed that we have got. I will also note it down that okay, that area is 4733.97, or you can say 4734. So I will note this down the area also here. I will tell you why I'm using this. So area of the catchment is 4734 kilometers square, right? And this is the lat long. So I will just save it. Now what we have got the catchment, we have got the streams in the vector format. Now the thing is, now I need to clip my watershed from these stream vector, right? Now I need to clip my watershed for the DEM also. Now the two steps that are remaining is that you the clip features. How to use this clip feature? What do I mean? What is the meaning of this thing? Is it means that right now I can see that there are uh, if I turn this stream vector off, you can see that all the streams that gets disappear from the watershed also. But I want that in my watershed the stream should be remaining. So what I will do, I will just clip the streams using this watershed boundary. So I will in the R toolbox, I will go to analysis tool where we have the command extract, and I will use this word clip. So in the clip feature, it is asking what is the input feature. So input feature is actually a stream vector, and the clip feature is the watershed that we have drawn as a vector file, the watershed of the Kurubhata as a vector file. And what is this coming out? This is coming out this year. The watershed is there, and the name of the watershed is the Kurubhata, and it is having the streams also. Since it is a feature class, it means it is going to be the shape file. I will save it, and I will say okay. Okay. So now if I turn off this stream vectors, you can see still I can have this streams in my watershed. Why? Because we have clipped the streams as per our watershed. So this is the, you can, I think you can understand now we are in a position to reach towards our watershed where we are having the streams available, and we can see the streams how the watershed at this outlet is contributing. Now the next step is I also want to clip the DEM. Okay, so I have the DEM of this uh, thing. Now I want to also say that which is the higher elevation, which is the lower elevation. So next step is that I want to extract the DEM. So in that case, I will use the statistics, spatial analysis tool, uh, where I will use the, you can say, the extraction, and I will extract by mask. Now I will not use the clip feature because now I want to uh, use the dem data also. So I need to mask that dem file into my watershed file. So I will use this mask feature. I will extract by mask. Now it is asking what is the input raster. Now input raster is my dem file because I need to extract mask that dem in my watershed. Now input raster is the uh, filled DEM, and what is the input raster or feature mask data? Mask data will be again the watershed of the Kurubhata in the vector format. And where you want to save it? Yes, I want to save it in that same location. Now this is the watershed of the location of Kurubhata, and this is having the dem information also. Now this is the raster data set. Now it is not the shape file, it is the raster form. So I will use the word TIFF here. I will save it and I will run OK. Now you will see that this cachement will now be having the dem information also. Now you can change this layout of this dem into some color format. So this is the file that we have created recently, Watershed Kurubata dem. You just click on this. There is in the symbology, layer property symbology, there is a color ramp. It is preferable that you use the color of this color codes indicates that from left to right the elevation is increasing. Suppose you have the blue, it means it is the lowest elevation, the red it means higher elevation. And since the river always flows at the lowest elevation, it is preferable that you use this blue color and go on to the red color. This is my choice particularly, where I follow this ideology and methodology that okay, my streams generally flows at the lowest elevation, so its color should be blue. So I use this particular color ramp, in which I used for the lower elevation the blue color, and the higher elevation we have the red color. I use the apply and I say okay. So now you can see that this is the uh, pretty good watershed that you have got at the location of the Kurubhata. You can see this is the location of the Kurubhata, and you have got this watershed. Now it might be possible somebody will be thinking that we are getting all those subsequent things also because I have opened all those layers. Now once you close those layers, you will see that you will get only and only this watershed. So I will just I will use I will close this 4-point outlet feature. So all those 4-point outlet have gone. I have used this flow accumulation tip file. I will close this flow accumulation tip file. So all these subsequent files have gone. And this you can say Kurubhata streams color. I will use this as blue color, and I will say okay. Now you can see so beautiful the watershed has been extracted, and this is our 4-point feature. You can say where we have taken. Now you can also change the symbol of this 4-point. You can make it little big. You can change the color also, make it yellow, any color as per your choice, may you go, so that it is visible. Okay, so this is the point where you have taken the 4-point. So at this location now it is showing you the watershed. Now we have the area also that we have calculated attribute table. The area is 4734. Now I end up this tutorial where in brief, in very detail, I have taken into consideration okay how to delineate the watershed. This might be useful. Many of us who are the beginners in ArcGIS, to start with, they have the dem file. They can start with their own. They can. I have already taken a lot of time in creating this video. I was pretty slow in my pace. But if you think that okay, you have the upper hand, then you can fast forward my videos and you can see it at a faster pace. One thing more that I would like to conclude here before I sign out with this tutorial is that I have noted down this lat long and the area of the catchment. I will tell you one thing, that there is a website also in which after entering the lat long you can directly get the shape file of this catchment, and also the area of that at catchment. So just to check it, they check it out that in ArcGIS, that all the analysis that we have done is what accuracy it has been there as compared to that site. So the name of that site is the Global Watershed. Okay, so this is the name of the website, mghydro.com oblique watersheds. In this, you can just delineate the watershed upstream of those points. So it is given that, okay, make results downloadable. I just entered the coordinates. So it is saying that enter the latitude and longitude pairs in decimal degrees, separated by space or comma. So latitude and longitude I have just noted down. So latitude is 21.987, 21.987, and longitude is 83.204. Okay, so I just delineate. You can see that it has gone to that location, the same location that we have taken. Now you can see that it has delineated so quickly the watershed. Now you can imagine the computation that is going on behind this website, how fast the computation is that we have taken so much time to delineate watershed. Now this has given the shapefile. And now you can also see the watershed area that it is given. It has given the watershed area of 4,700 kilometers square, and our area was 4,734. It is pretty good. 34 kilometers square area. It is due to dam that we have taken from the Cartoset dam, and I don't know the global watershed which dam they are using. So more or less, it gives you a very fair idea. Okay, what is the what will be the watershed, what will be the spread of the watershed. So using this website, it will be easy for you to at least analyze that how much dem file, how much dem tiles you need to uh, analyze your watershed. I hope it is very much clear for you that, okay, you have drawn your watershed. Also, you can add the base map beneath it. There are a lot of things in ArcGIS where we can learn a lot of things. You can add the base map. So there is an option from here, add base map, so that you can see that, okay, at which location you are there actually. So the same shape you can see that you have got as here also. There is no difference. Okay, so this is all about the watershed delineation. And at the end also, I was showing you in PPT that, so you will end up, okay, this cartography, this is the cartography, that how you have mentioned this latitude, the longitude, the legend, the north. All these are the part of the cartography. In the subsequent uh, videos, I will try to incorporate the cartography also. You can see that, okay, so this is the river of my concern, and this is the catchment that has been drawn when I have overlaid the base map. You can see this base map of the world imagery when I have seen. So this is the complete tutorial. I hope it is pretty much clear from my end. Okay, so if there are anything that you want to ask, or you want to have any query, I have taken up this thing in very much in detail, because as a beginner, this I think will act as a basic tutorial for you to start to give a push to your ArcGIS learnings. I hope it is pretty much clear. As of now, I am signing off. It is almost 1 hour that I have been making this video, but I hope it will be beneficial for many of us. Thank you. Thank you so much. If you have any query, definitely you can ask to me. Okay. So I just sign out from this video. This is the watershed that I have made. Okay. Thank you. Bye bye. Take care.